Our last talk for this morning's session is another APL team, Dan, who's from AMDS, and Mike is from COM, and they'll be talking about creating avatars of actual people.
Hi, I'm Dan Levine. Let's see. I think the best way to put this is, so when you're making your AR worlds, you can have any characters you want, and so we were trying to come up with, well, how hard is it to actually make it look like somebody you know? Now, we're not really trying to impersonate the person. We're trying to get close, but we're just trying to see, well, how hard is that? Okay. So let me see if I can get this working. Okay. So I cheated and ran to my first slide. So I already kind of told you, these are the things we're going to talk about. Okay, so what we're trying to do, a bunch of things like this. We're going to just move on real fast because we're going to cover all this. So really, the way this originally started was Central Spark wanted, I guess, some kind of, I don't want to say chatbot, but some kind of persona that you could walk up to, ask a question, and have it research the answer, and then respond back with the appropriate answer, and perhaps continue a dialogue. That was the essential concept of what we were trying to do. And so we have achieved various parts of that project. Okay, we're going to show you mostly the making it look like somebody in particular, and a little bit of the interaction capabilities. Okay, so but what we're trying to do here is to make it as easy at APL to get a model of yourself that can be animated and manipulated just as easily as you could go to COM right now and get your professional portrait. Okay, so we're working on what is that process so that it's not new every single time. Okay, and so I already talked about the Q&A kiosks. Oops, always helps if you hit the right button. This is Mike. Hi, this is Mike.
Hi, this is Mike. I'm from COM. I'm a 3D artist in COM. So my role on this effort was to find the way and tools and pipeline for specifically what Dan is explaining, which is like, how do we take a picture of somebody and then run it through a bunch of programs without doing a ton of work. So this is the standard pipeline for if you want to create a realistic animatable human face or body. 3D sculpting, texturing, retopologizing, rigging, animating. Those last three are probably the most technical and really tedious to do. So we started kind of looking at what was available and what we could use to create that pipeline. So we started with Dan, and what we did was we brought him into our photo studio in MP2. We set up this really bright lighting environment with a bunch of light reflectors and everything to eliminate as many shadows as possible. And then what we did was we sat him down and we had our photographers do like a whole 360 shot looking down at him, looking straight at him, and then from underneath so that we can capture all the angles in high quality, as a high quality photo. So after that, we used a program called Reality Capture, which is great for photo scanning and processing photos and turning them into 3D models. And so we loaded all of those photos into Reality Capture, ran it, and then it gave us this raw scan mesh, which was around 11 million polygons. So we know from there we have the sculpt made and we have the texture made, but now we need to do the last three steps, which is optimizing it for animation and more editing. So the raw data did come out, sometimes a little bit imperfect, so it still requires a little bit of hand from an artist to bring that into, in my case, I brought that into Blender, and then I cleaned up the mesh using sculpt tools and all these other things, looking at the photo, at the original photos for reference, making sure I'm not like deleting geometry or expanding geometry that shouldn't be there. And then everything is kind of retextured. I mean, the texture is just brought in as is. I don't really mess with the texture. So that texture is the photo data. That's why it looks so realistic. And then the geometry comes from that. So first, what we thought we would try is using Unreal Engine and MetaHuman. So MetaHuman is this tool by Unreal Engine that is created for creating really realistic humans and animating them and all these other kinds of things. But what we ultimately wanted to do was we wanted to take our model and bring it into Omniverse, which is an NVIDIA program, and we wanted to go further than just animating the face. So we tried using Unreal Engine, but we ended up having some difficulties, like not being able to animate the body and the face at the same time. In Omniverse, there's also a lot of restrictions on MetaHuman Creator and Unreal Engine itself. It's like kind of closed. Like you can't take the MetaHuman models out of MetaHuman Creator and bring them into your own program to continue making edits to them. So you kind of have to work with the limited tools that they have, and if you wanted to do any customization for other body types, other facial features, hair, anything like that, you kind of don't have that flexibility. So it gave us pretty good results, and we were able to get at least a head, animated and get something close. But we ultimately ended up going with moving forward into another program called Character Creator by Reallusion. And essentially, they have this plugin called Headshot 2, which does the same thing that the previous slide showed, which is we bring in the 3D scan, we match it up with a mesh, a face mesh that they already have. We mark a bunch of points on like the eyes, the nose, the tear ducts, all these landmark pieces. And that's really important because every face is going to be different. So it'll do an automatic pass, but then you can go in and add points and features that you want to come over in the translation. And what it does is it takes those points, that photo scan mesh, and reapplies it onto a more optimized, rigged, and ready to go animated face. And then it just gives it a body. You can adjust features inside of the program. You can give different clothes. And then that thing, that like human, that character, looks like the person that you want it to look like proportionally. You can make changes. You can really customize a lot of stuff. But the best part was that those models from Character Creator we can take into Blender and make further changes, and we can bring back into Character Creator and then work with their tools. We could also take that entire model and bring it into Omniverse and then bring it back to Blender. And there's a lot more openness to collaborate, like in using different types of programs. And so I'm gonna hand it off to Dan, but after we have the character created and everything is set, it goes into making them talk and bringing them to life.
Thanks. And so one more thing. So we kind of talked, Mike talked a little bit about how we switched engines. And so that one of the biggest problems when we were using the first one was that we sort of had two programs. We had one that was animating the face and the body potentially, and the other one which was just showing the face and being told how to animate it. And so it worked, but the problem is it was kind of brittle. It was two different companies, and so the more we could simplify that, the better. And that was really the driving force for, can we get this model out of this program and just put it all in one environment? Okay, so that was the driving feature that we were looking for, and it also helped us overcome other things as well. So we'll show you a little bit more. So not only did we want it to look like the person, but we also wanted it to sound kind of like the person. So we actually tackled a little bit of that too. Okay, so that was my part. And so we used a number of different NVIDIA tools, which I've put in here. So I could talk about these in horrible detail with you, and I have to admit, it's quite a learning experience to come up to speed on the NVIDIA product line. They have amazing software demos and things that are available, and their hardware is wonderful too. One of the biggest problems, I would say, though, with NVIDIA is if you just want to say, hey, I want to make text-to-speech capability that sounds like person X. They have all the stuff that you need to do it. But the problem is it's not kind of like the equivalent to, I want to learn how to bake a cake, I go to the store, I go get the Betty Crocker box, and I have all the pieces, I put them together, and I'm pretty good. I don't have to add too much. Their version of baking the cake is more like, well, first, you're going to have to get some seeds for the wheat. Okay, go plant those, water it, take good care of it. Anyway, so you can see everything's there, but you have to really work hard to put it together. So you might be able to do similar things with other products that it's not that they're more mature, but it's more like, I want to live at this level, not this level. But what they do give you is what I would say is ultimate control in what is going on. And so you have to actually care about that. So in our case, we're sort of in the middle there somewhere. Okay? And so they have a bunch of different services that you string together. And so what I'm talking about here with creating text-to-speech capabilities, essentially I took 3 demos of theirs that were all completely separate, demonstrating completely different aspects of building a text-to-speech capability. And then I stitched them together into a pipeline that to me seems absolutely obvious, and why there isn't one demo that doesn't do that, I don't know. But I worked really hard to make these Python notebooks that they provided into something that someone could actually use. Okay, and so it turns out I'm involved with Central Spark, and what I'm trying to do is make something called a Makeable, and they have a site for that where you could download these Python notebooks, and you can walk through different versions of such a demo. So what I've created is something where you can walk through, suppose you don't have any audio data, you can walk through with their sample audio data from step 1, step 2, step 3, great, and you can do text-to-speech. I have another one where it's like, oh, well, suppose you actually do have your own audio data. Okay, here's what you would have to do. And so if you're interested in that, this is not the end. You can just come see me and I can show you that. I don't show you how to run that here, okay? So, yeah, so there's all different kinds of NVIDIA stuff, okay? And they have a whole speech skills capability. And I've demonstrated both the speech-to-text transcription capability, similar to what Blake was doing. And I also have the opposite, which is type this, make somebody speak. Okay, now what they normally give you is make some generic male or female sounding character speak. What we've done after that was we made it sound like, in this case, me, because we have a model of me. Okay, but anyway, so that's what we're really trying to do. And then Nemo, it turns out, that's how you fine-tune the text-to-speech model. Actually, really, most of their models Nemo is how do you make it sound like what I want, okay? And then Triton Server is sort of a way to say, well, you could have a Python notebook, and you load in the model, and you run it, and I'm in full control of what that is, and I say, go do this, and it does, and that's great. And it's sort of like one at a time, I submit something to the model. What Triton is it's more like, I have a server. I can submit text-to-speech requests to it, and it's fielding it like at the enterprise level, and it's scalable, and it's crazy. And I know when you first start off, you're going to be like, no, I don't really need that. But if you ever make anything for real, you do. Okay? And so what's really nice is they have that. Okay? So you can start small, and you can get bigger. And I'm not really like a super-duper expert in NVIDIA, and even I was able to get it working. Okay? All right. So, fun thing. So suppose you have a model of a character, and this obviously is not me. Some of the neat technologies that NVIDIA gives you in their Omniverse is something called audio to face, and it's exactly what we said it is. Okay, you can take recorded audio or generated audio. It doesn't even know what you're saying, and it doesn't have to be in English. Okay, and it has been trained already by NVIDIA to take that audio and move the face around to make it look like it's saying it, okay? And by the way, I should also say, we have a demo at 3 o'clock if you want to come by and see us in another room where we will agonize and tell you all about all the details and stuff. We have little demos here, okay, to keep this sort of short and sweet. So, okay, so the next cool thing is, well, yes, you could have a very blank face doing all that. They have another capability that's really awesome too, which is audio to emotion. And so if you don't want a robotic face doing it, it attempts to read from the audio what the emotions are periodically, and it adds that in. And I should probably do this while it's going. So this is them just dialing it up and down for this particular figure. And so you can see, this is just a model. This is not a real human being. So you can really go pretty far. Okay, still needs a lot of work, I believe, but it's just kind of like, wow, that's really cool. We don't have to do anything. We don't do anything. We almost don't do anything for this except stitch it all together. Okay, then there's a final really cool capability that we just started playing with, which is audio to gesture. So this takes the audio, and it, instead of just having the head stand there talk, it kind of goes like this, and it gestures, or maybe there's a couple modes. One can be like, oh, you're behind a podium, so you're not going to go walk all the way over there. And so you'll get to see a little bit of that too. I think we actually have a demo of that here too. So we'll just show you, and we are not doing anything other than playing the audio in there. Okay. One thing I should mention, Blake kind of mentioned it at one point. Our text-to-speech capability, which is really NVIDIA's text-to-speech capability, does not seem to inject emotion. My guess is it's only a matter of time because they have all the other stuff. Okay, so at the moment, I would say it's not emotionless, but it's not very emotive. Okay, and so therefore, there's probably not a lot to drive the face that way other than making it talk. Okay, all right, so let's see what we've got here. Okay, so what can we do today? So we at APL, not that we're that amazing, but we now have a pipeline where we can actually take a couple hours of data from people who have spoken that long, including me, and we can make it sound kind of like that person. And given more training and more data, we can sound a lot like that person. Okay, so that's cool. And so we've done me, and because we have a lot of audio from Dr. Semmel, we've done him too. Okay. I think if I hit this button, I will get him to say something that he's never said before. So this will be text-to-speech of Dr. Semmel.
Hi, I'm Stash GPT, a generative AI version of Dr. Semmel. I'm here to talk to you about something really exciting going on. It's a new initiative called Level Up, where we are looking for ways to safely integrate the power of generative AI into use at APL by all staff in the performance of their work here.
So it's not bad. It's a little robotic, but nevertheless, this was not done on millions of dollars of computing. And I also feel like the longer it talks, the more it kind of drifts away from being believable. But for a question answering kind of bot, it might work if the answer is like a sentence or two. So, so you can imagine what we were trying to do was you walk up to a Dr. Semmel robot and you ask them, hey, when was APL founded? And it goes and it looks up the answer and it comes back and it does that. So that's kind of where we're sort of trying to head. Okay. Okay, we have custom 3D avatars of a specific person. In this case, me, because I was readily available at the time. We didn't want to hog Dr. Semmel for several hours to try and work it out. Okay, we're still not ready for you call up COM, set up the appointment, and we're done. We're trying to get there, okay, but we're getting close. We can do text-to-speech for animation of the body and the face, and we can also use pre-recorded as well. And, of course, we also have English-to-speech recognition. You can do other languages, too. I just haven't played with it, okay, but they're just out of the box available as well. Okay, so we have a video we can play. Let's see what happens. So this is mainly audio to face and audio to gesture going on. And what I should also add is, I know it seems like it should seem really trivial to do, and maybe it will be when we play with it enough, but when we're working with it, the audio to face just wants to do like a bust, okay? I don't know why. It's just the nature of the thing. And the audio to gesture does the whole body, but it doesn't move the face. And so we are working on putting the talking face on the moving on the moving body. Okay. At the moment, we don't have that to show to you. Hopefully, by the end of the summer, we will have figured that part out. Okay. So what you're going to see is two parts doing two different things. Okay. So let's.
And so I had a different idea. I had a range top that was broken. And actually, it wasn't the whole range that was broken, it was the knob, and there was something that basically adapted for this knob. It was like a half moon kind of insert to a square post kind of thing. And so I was like, well, that's a pretty simple shape. So I learned how to engineer that up, and I figured out that it's a lot harder to make something on a 3D printer that fits something that's actually real as opposed to just sitting and using gravity to sit on a desk. Okay, and so
Okay, so not bad. I wish I had hair here, and they have actually done work to get the hair, but in order to get it through our approval process, we were like long gone after that. So I believe in the other room, I'll have hair where I'm happier. Okay. All right, so what's next? Okay, so we want to work on Dr. Semmel before he leaves. David Castleberry is also in the mix. He's our Central Spark facility person over there. We kind of want to capture him. Again, I had mentioned sort of question answering, and it kind of goes similar to what Blake was sort of talking about. Hey, can it hear a question? And so what we really want to do is we want to have a streaming audio. We don't want to push the button kind of thing if we don't have to. We want it to hear a question in there somewhere and then say, oh, okay, that's a question. I want to go find the answer, have it then respond in the audio of the avatar. Okay, and maybe even with follow-up dialogue, and maybe even something a little cooler where like maybe you ask Dr. Semmel in the lobby of APL what's for lunch, and well, maybe Dr. Semmel shouldn't be the one who answers, but maybe he can introduce you to the people who are in charge of making lunch, and then they can actually handle that, so they can defer to like another expert. Vision processing. So it would be really cool if the avatar looked at the person who seemed to be speaking to them, or could see that they walked up, or see that they walked away, that kind of thing. Yeah, there's some other fun things about the kiosks, especially if you have the audio going all the time, which is privacy kinds of things. And so we'll have to work our way through all those. But at the moment, we're just kind of having fun. Lots of people helped us get here. Okay, so it looks like we did this. Okay, so not only did NVIDIA and some other companies help us, but these other people were all instrumental in assisting us in various ways, whether it was capturing the photos, providing money, getting us the audio, doing whatnot. And I wanted to mention Chris is here. Chris Chu, over there in the corner there. He's doing all the hard work. Okay, he's our Aspire intern. I like to think of Chris as like the headlights on our car. Okay, we know we're heading towards X, and we're working, on this kind of thing. And we'll just throw something to him that's a little bit down the line. He'll go work on it, and he'll come back to us and be like, you mean like this? And it's like, yeah, write down how you did that. We're going to be there in a second. Yeah, we want to so for example, he figured out how to put hair on the talking head. So that's why we have hair on the talking head in the other room now. Okay, so among other things. Okay, so anyway, so special thanks to him. Make sure you come up and talk to him at our demo too, because he's probably the one who knows the most how it all works. So if you have any questions, you can come see us. Oh, it's before lunchtime. You can even ask us now. We'll be more than happy to talk to you. Thanks.
Are there any questions for us?
Oh, in the back. Oh, here, you need a microphone. Or they're gonna beat you up if you don't use the microphone.
This is more of the what's next variety. As you bring the elements together, how much of AI thought are you putting into a particular type of AI to help fuel the question and answer portion of that? And then what are you using as a backbone potentially to, when everything comes together, what's going to power all the different functions coming together? How much computing power do you think might be needed?
Okay, so let me see here, see if I can keep all this. So we initially were gonna go tackle the question answering problem, but then we found out other people were already doing that. And so, unlike what normally happens at APL, we decided not to pursue that. Okay, because they're the experts, and that's good. We've seen, there are some demos that we could very easily leverage that do the standard process, and NVIDIA even provides like containers that do such things. And so we could do that. But I think what we were trying to build was something that was sort of a plug-in for the question answering. I'm envisioning that we're kind of really our team at least is working the front end. Can we make the thing talking to you look like they're saying what they're saying to you? Can we make it look like they're listening to you? Once we capture that information, and we could probably fire stuff off to ChatGPT if we really wanted to, depending on what the expertise was. But we would fire off to something that would have the expertise to answer and then give us what I would consider maybe a brief response, something that you'd want to sit back and listen to as opposed to like a half-hour answer to the question kind of thing. Compute-wise, we are doing the face on a computer. It's a laptop. Now, it's not your everyday laptop. I remember, a number of years back, it was hard for us to get a laptop that had a GPU. My guess is nowadays it's hard to get a laptop at APL that doesn't have a GPU. You need reasonably powerful processors. probably a little bit more expensive than what just normally gets ordered. Like an RTX, couple thousand, something like that, but it's a couple $100, like $400 worth of processing. Okay, so it's not like, wow, nobody has that. Pretty soon, everybody's going to have that on their desk. Okay, now training-wise, we used GPU Central, if you're not familiar. So you can go into My APL Cloud with the right permissions, and they will give you a cloud computer with a decent amount of GPU compute. Okay, and I would say it's for free. Okay, we didn't pay, we didn't give a budget, nothing. Somebody's paying for that, I don't know who it is. And so for the training, I would let it train for many hours on the hours of data that I had to make it sound like me. Once that's done, once you have that model, you don't really need anything like super-de-duper-de to do the text-to-speech stuff. You still need a little something GPU-wise, but it's the training that costs the most, it would seem. So, oh, another question?
Now it's on. Okay. As you were exploring this, were there technologies in place that would allow you to emphasize words, or is that not happening yet?
So, okay, so we're talking text to speech, right? Because it's very easy for me to do that. Okay, that's the easy part. So this is sort of where I was saying that the text to emotion is probably like the thing that's kind of missing in here. There is none of that, at least in the NVIDIA product line. But there is something. So there is like an XML language that you can use where if you wanted to, you could embed tags and add emphasis or slow things down. But that's not automated. But I would think that that's coming.
But if you had something that generated that XML, you're saying that it would, the speech would emphasize it the way that the tags said. Yeah,
I believe that is correct. Yes. I didn't play much with it, but yes, I believe that's correct. There's a very trivial XML language that allows you to do things kind of like that.
And presumably you could train AI models that would learn how you emphasize things and pretend to emphasize.
That's true. Everybody would do it a little differently, and so you could train it that way, or it could even be generic from a certain point of view. So, but yes, and it could probably also pull it out of the audio. So we're doing, well, actually in my case it was audio. Well, no, it's really text to speech. That's the problem. The text is just text. So it would probably be another generative. He just starts stacking the models up. So it would either be another generative AI model, or it would be fused in with the other audio generating model that would then produce either the tagged data, which would then produce the audio that sounds like the text that's tagged, or it would just infer it and go with that. And then that audio would drive the audio to face and the audio to emotion. So that's the only part that's missing. I can't believe it's not coming. But I haven't heard anything, and stuff just shows up from NVIDIA, and it's like, oh, that's kind of cool. So you never know what's coming, but I cannot believe that they wouldn't do that given all the other parts that they have.
All right, well, that's time for this session. If you have more questions, please stop by the presenter demos, which are from 3 to 5 this afternoon in both of these conference rooms. So Dan and Mike will be there to answer more questions. A big thank you to all of our presenters who have given us talks this morning. Thank you, everybody.